The Wankel engine, or more commonly known as a rotary engine, uses a tri-point rotor similar to the mathematical rouleau triangle to help power the engine. The rotary engine was invented by Felix Wankel in 1954. Felix reportedly came up with the idea when he was only 17 years old. In 1924, he set up a laboratory to try to create his engine. However, during World War II, he brought his work in the German Aeronautical Research Establishment, where he brought his knowledge of rotors. He later worked at NSU Motorwork, where he debuted his engine to the world. So, how does a rotary engine compare to a piston engine in its working? A piston engine works a little something like this. As the piston moves down, the lid on the left opens to release the air-fuel mixture. As the piston moves up, the mixture is compressed. Here, it is ignited by the spark plug up at the top. The basic mini explosion that happens inside the engine expands the gases, which pushes the piston back down. This cycle happens over and over again, moving the camshaft, which moves the drive shaft, which moves the differential, and moves the wheels. A rotary engine, on the other hand, accomplishes intake, compression, combustion, and exhaust simultaneously. As the rotor moves, it intakes air and fuel through this point. The rotor continues to rotate, and due to the shape of the housing, the mixture compresses. Here, it passes by the spark plugs, which ignite the fuel, expanding the gases and moving the rotor. The exhaust is released at the end. Again, it is important to remember that this is all happening at the same time. This continuous motion allows all three processes to occur simultaneously, increasing the power obtained. One benefit to the rotary engine is its high power-to-weight ratio. This allows for the engines to be small, compact, and fit anywhere. In fact, the rotary engine can have a power-to-weight of under 1 pound per horsepower. This means that with only 2 rotors, you can get the same amount of performance as most naturally aspirated 6-cylinder or even 8-cylinder engines. Another advantage of the rotary engine is the fact that there are fewer moving parts. It is often in mechanical engineering that the simpler machine is the better machine. Less moving parts should equal less things to go wrong. This is why engineers love the easiest and simplest solutions. The final advantage of the rotary engine is its smoothness. The piston engine has an oscillating and reciprocating mass in the form of the piston itself. This causes the engine to vibrate excessively and to be unstable overall. The rotary, on the other hand, rotates in a circular fashion. This creates a much smoother engine and allows it to rev high, sometimes even up to 12,000 RPM. So, I have listed all the benefits of the rotary engine. They seem good and fair, but then why don't we see them anywhere? The last rotary engine car, the Mazda RX-8, rolled off the production line in 2012. Why did the rotary engine have to die? It all has to do with 2 factors, emissions and efficiency. The disadvantage to the rotary greatly affects these 2 factors. One disadvantage of the rotary is its low thermal efficiency. Its oddly shaped combustion chamber leads the engine to be less thermally efficient than a piston engine. This allows unburnt fuel to go into the exhaust. The fuel igniting causes the backfire effect, with fire coming out of the tip of the exhaust. As fun as it may be to melt the bumpers of tailgaters, it leads to the rotary being inefficient as fuel is wasted. The second disadvantage is the oil required in the rotary engine. To properly lube the housing of the rotor, you must coat a large area with injectors. However, because of the large amount of oil, some oil can get into the combustion process and burn up. This causes nasty chemicals to be released through the exhaust, which is bad for the earth. It is chiefly the 2 factors of efficiency and emissions that led to the death of the rotary engine. However, there may be hope for this triangle-powered engine. Rotaries are being run with hydrogen to solve the problems of emissions and efficiency. They are also being considered in EV vehicles to charge the battery, as they can be very small and compact. Although Felix Wankel's engine failed to be the future of engines, the technology he invented is not doomed quite yet.